This video is going to look at possibility diagram, which is probability for multiple events. In previous lessons, we have done calculations of probability for types of outcome that is not many. Example, 50 marbles but 2 colors, people and types of gender, either male or female, the weather, whether it's raining or not raining. When we have a lot of types for possible outcome, such as digits in 2 dice, there will be too many possible combinations such that tree diagram will give too many possibility branches. This is where possibility diagram help by organizing multiple events by tabulating the different combinations. Let's have a look at the question. A blue die is marked with digits 1, 3, 5, 7, 9, and 11 on its faces. A red die is marked with digits 1, 2, 3, 4, 5, and 6 on its faces. When the dice are tossed, the score is the number on the face on which it lands. The 2 dice were tossed together, and the outcome of the scores on the faces were recorded. Complete the possibility diagram. To fill in the table, we fill in the table of values from the vertical column, and we do the same for the horizontal row. This is how it should look like when the table is completely filled up. Now let's have a look at the question. What is the probability that both numbers are divisible by 3? By inspection, there is 4 cells. So what is the probability? Going back to the formula, probability is a fraction of number of events over total events. There is 4 events. What is the total event? The total event is the combination of all possible outcome which is in the outcome space. Where 6 row by 6 column, there is 36 possible combinations of the outcome, which means the probability of both digits which are divisible by 3 is 4 over 36. Lowest term, 1 over 9. The next part of the question is looking at a different outcome. The scores from the 2 dice are added together. Now the scores from the 2 dice means that we have to look at the data in a different way. This means that the 2 combinations from the dice are summed up, and so we should see the values differently. So like the first cell is 1 plus 1, the next 1 plus 3, 1 plus 5 is equal to 6, and so on. So let's answer the question. Prime numbers. By inspection, there is 14 prime numbers, and so the probability is 14 over 36. Lowest term, 17 over 18. Next, divisible by 5. There are 7 values for this, and so the probability is 7 over 36. Now let's have a look at another question. 2 fair dice are thrown together. Find the probability that the sum of the resulting number is odd for prime numbers. We are looking at the outcome for the sum of the scores. We can construct the possibility diagram as such, adding immediately the 2 scores. First thing we always have to obtain is the total possible outcome. In this case, it is again 6 by 6, which is 36. Now let's have a look at the outcome that are odd. by inspection. Let's count. There is 18 possibilities, and so the probability is 18 over 36. Lowest term is half. Next, prime numbers. There is 15 outcome, and so the probability is 15 over 36. Lowest term, 5 over 12.